classify the isolated singularity at the origin for the given function. Sine z over z, cosine z over z, e to the z over z squared, 1 over z to the fourth, e to the 1 over z. So we'll start with sine z over z. In order to classify the singularity, we need to write the Laurent series for the function centered at the origin. And the Laurent series for sine z over z is 1 minus z squared over 3 factorial plus z to the fourth over 5 factorial, etc. And then to classify the singularity, if there's a power of 1 over z to the k, if there's a negative power of z, if there's a term of the form some coefficient times 1 over z to the k in the Laurent series expansion, then we have a pole. And if we find the largest k among all the terms of this form, then we have a pole of that order. Well, there are no terms of this form in this Laurent series, which is actually a Maclaurin series, which means that there is no pole. There is no pole for this function at the origin. Instead, the singularity is simply a discontinuity at the origin. On the other hand, if we look at cosine z over z, we will get a term of this form in the Laurent series, because this one is 1 over z minus z over 2 factorial plus z cubed over 4 factorial minus, etc. All of the other terms here have powers of z in the numerator. The only term that has a power of z in the denominator is 1 over z. And so the largest power of z that occurs in the denominator is 1. So we have a pole of order 1 at the origin. And a pole of order 1 is called a simple pole. We have a simple pole. The singularity at the origin is a simple pole for the function cosine z over z. Now looking at e to the z over z squared, e to the z over z squared is equal to 1 over z squared plus 1 over z plus 1 over 2 factorial plus z over 3 factorial plus z squared over 4 factorial, etc. And so we have two terms of the form 1 over z to the k. We have 1 over z and 1 over z squared. So the singularity is a pole, and the order of the pole is the largest power of z that we have in the denominator. So we have a 1 and a 2. The largest is a 2. So we have a pole of order 2 at the origin for the function e to the z over z squared. 1 over z to the fourth is its own Laurent series, and so the largest power of z that we have in the denominator is 4, so this one has a pole of order 4 at the origin. And finally, e to the 1 over z is equal to 1 plus 1 over z plus 1 over 2 factorial times 1 over z squared plus 1 over 3 factorial times 1 over z cubed plus 1 over 4 factorial times 1 over z to the fourth, etc. So we have infinitely many powers of z in the denominator, so there is no largest one, and this is called an essential singularity at the origin. So we have a discontinuity, a simple pole, a pole of order 2, a pole of order 4, and an essential singularity. amongst these 5 functions.